number 6. Find probability of Z lies between negative 2.696 and 1.865. In this one, you can see that we have a negative value and a positive value. We need to find the probability in the form of Z lies between a negative value and a positive value. So let's represent this graphically to have a better idea what we are trying to find. So if I draw my normal curve, I can see that I have a negative A on the lower tail, a positive B on the upper tail, which means that we need to find this probability, and this probability phi of A plus phi of B minus 1. And I'm not going to show you where we got this, just the result. We're going to take the phi of A, which is 2.696. You can see we only take the value, we do not take the sign, plus the phi of 1.865 and then 1. Next part we use table. We have to find 2.6 and then 9. So we have 9964 plus 6, which is 1. So we have 0.9965. You add with the phi of this one, which is 1.8. 1.86. So 96, 86. You add with 4. We have 96, 90. So we take plus 0.9690, you minus 1. 0.9965 plus 0.9690 minus 1. We have the probability 0.9655. Number 7. Suppose we want to find the probability of Z lies between negative 1.4. Number 7. Suppose we want to find the probability of Z lies between negative 1.4 and negative 0.6. We can start, we have a negative value and a negative value. We're going to have here negative 0.6 and then we're going to have negative 1.4. So which means I'm going to find the shaded area here. I represent this by negative B. I represent this by negative A. What do I have? A probability that negative B less than Z less than negative A. It's going to be the same as phi of B minus phi of A. Notice that I have taken minus B here and then minus A. So this is my minus B, this is my minus A. So whenever you have both negative and both are on the lower tail, we take phi of B minus phi of A. Phi of 1.4, you minus phi of 0.6. So 1.4 and then 0, because after 4 we have 0. So we have 0.9192. You minus 0.6. After 6 we have 0, which is 0.7257. 0.9192 minus 0.7257, we have 0.1935. You can always give your answer to three significant figures, but for now we're going to just stick to finding the probabilities. Number 8. This time we want to find the probability that modulus of Z is less than 1.433. Whenever you have modulus of Z less than a particular Z, it's the same as the probability of Z lies between negative 1.433 less than 1.433. A negative Z to a Z. Negative 1.433 is going to be on the lower tail. The positive 1.33 is going to be on the upper tail. We need to find this shaded area. Let's suppose this is minus A and then this is A. If I want to find the probability of modulus of Z less than A, it's the same as the probability of Z lies between negative A and A. This is the same as 2 phi of A minus 1. So what is my A? 2 phi of 1.433 minus 1. Let's use table to find the phi. 2 multiplied by 1.4 and then 3, which is 9. 2, 3, 6. You add with 3. 3 is 4. You have 9 to 40. 0.9240. You minus 1. 2 times 0.9240 minus 1, which is 0.848. So we have it, the probability that modulus of Z is less than A. Number 9. Probability of the modulus of Z is greater than 1.433, which means that we need to find a probability that the modulus of Z is greater than A. If we want to find the probability of Z less than A, we find this shaded area, the less part. But if we have a greater part, which means that we need to find what? This side plus this side. So you get it, right? Lesser part, you need to find this part. But for the greater part, we need to find what? The probability of this shaded part here and this shaded part. My negative A is here, my positive A is here. So this is going to be the same as what? We need to take what? The probability of Z is less than negative A. So we're finding this part plus the probability of Z greater than A. This probability. We take probability of Z less than negative 1.433 plus probability of Z greater than 1.33. So you solve. So you find this probability plus this probability. Now we know that this probability is the same as what? Probability of Z is greater than 1.433 plus probability of Z greater than 1.33. Now what is the probability of this one? 1 minus phi of 1.433 plus 1 minus phi of this. Right? Now you have this plus this. So which means that we have 2 bracket 1 minus phi of 1.433. This is the same as 2 bracket 1 minus phi of A. I've done the proof only for this one, the last one. Probability of modulus of Z greater than 1.433. So we simply take what? 2 bracket 1 minus phi of 1.433 equals 2 bracket 1 minus, which is this 0.9240. So 0.9240. 1 minus 0.9240, you multiply by 2. So we have 0.152. Summary of what we have done. So we have seen 9 important results. The first one, we've seen that probability of Z less than A is equal to phi of A. Number 2, probability Z greater than A is equal to 1 minus phi of A. Number 3, probability that Z less than negative A is the same as the probability of Z greater than A. Number 4, the probability of Z greater than negative A is the same as Z less than A. Number 5, probability that Z lies between A and B is the same as what? Phi of B minus phi of A. Number 6, probability that Z lies between negative A and B is phi of A plus phi of B minus 1. Number 7, probability that Z lies between negative B and negative A is phi of B minus phi of A. Number 8, probability that modulus of Z is less than A is equal to 2 phi of A minus 1. And lastly, probability of modulus of Z is greater than A is the same as 2 bracket 1 minus phi of A. So it is important that you know all these results for you to be able to find probabilities. Next, a few exercises for you to work. You're asked to find the different probabilities based on what we have seen, the 9 important results.